Okay, guys, have a nice day. Today we are going to learn about recursion using Scratch. And in order to introduce recursion, so first of all, I think you should know the basic control structures, which is sequence, selection, and repetition. Sequence means basically all the instructions are executed one after another. So that is in order. So without any alternative paths. The instructions will be executed one after another. The second thing is selection. In the selection, there will be alternative paths. For an example, let me take two numbers, add them together, display the total, and you can see two numbers, take two numbers, add them together, display the total, it is sequence. If you take two numbers, compare them and display the largest number from those two inputs, so you have alternative. So that means when there are two numbers, you have to decide whether the number one is largest or whether number two is largest. If number two is the larger number, then you have to display number two. If number one is the largest, then you have to display number one. That means you have alternative paths. In real life, let's say you're in a junction, you have to decide whether to turn right or left. You can't turn both sides simultaneously. You can't turn both sides same time. So here, the third control structure is repetition. Repetition means repeating the same thing again and again and again. So you do the same thing again and again and again. So let me do a small example and show it to you. I'm going to use pencil. So yes, that is meaningful if I use that. So let's add pencil there. And I'm going to delete the sprite, this one, and I'm going to do some drawing using the pencil. So let me reduce the size to 30. And this is to show repetition, right? So I have already explained sequence selection, and this video, I'm not going to explain about them. So if you need, you have other videos in the same channel explaining about those control structures. And let me do repetition quickly and then go to the recursion. So in the repetition here, so let's say I want to draw a triangle. So triangle has three sides, you know that. And I'm going to start with the flag click when the control is, so I have a few choices, either repeat 10, so that will give limited repeat times, 10 times actually, forever, which will be repeating continuously. This is actually used in the game loops, because in the games, we have to continuously repeat the same thing until the game over. So then there is another one, repeat until some condition. Maybe this can also be used, repeat until game over, something, right? So let's say repeat 10 times. We can do some activity 10 times. Forever, it's doing always. And repeat until, we'll do until a certain condition. So since we need a triangle, I'm going to repeat 3 times because I need a triangle. And so I have to set up the triangle starting position. So let's start the triangle with 0, 0 position in the screen, which is middle. Then let me start with the direction 90. So direction 90 means I'm going to draw from left side to right side, right? If it is direction up or 0, then it's going to draw from bottom to top. Here, left to right. Here, actually, top to bottom. And here, if I use minus 90, it will be right to left. So let's use 90, which is left to right. I'm going to draw this side. So then I'm going to move 10 steps, 100 steps, and then turning. I'm using the left turn, which is, so let's say for triangle, the internal angle is, so here if it is a triangle, so I have to draw like this. So the internal angle is 60, 60, and the external angle is 120. So what I'm going to do, I have to turn 120 degrees, that is external angle that you have to mention here. Actually, if it is a triangle, 120. If it is a square, it is 90. If it is hexagon, it is 60. It will be 360 divided by the sides. If it is triangle, 360 divided by 3 is 120. If it is a square, 360 divided by 4 is 90. If it is hexagon, 360 divided by 6 is 60. So I think you can understand how I'm going to find the external angle. So okay, here it will be 120. 20. And let me run the program. You can see it's quickly drawing a triangle. So if I want to slow down, let's go to the control and wait 1 second after each turn. And when I play this 1, 2, 3 sides, it is 1, 2, 3 sides, but it's not drawing there. So we have to import the drawing tool, or we have to add that extension. So to do that, I'm clicking on the extension button, which is in the bottom left corner, then add the pen. First of all, I have to clear the screen, that is erase all. Then I have to pen down to draw this line. Okay, let's play it. 1, 2, 3 sides, and this is the triangle line. Okay, this is repetition. If I need to change this to 4 sides, let's add 4 here. So it will create 4 sides with 90 degrees, will be square. 1, 2, 3, 4 sides with that is square. Right? If it is pentagon, it is 5 sides. If you don't know how to calculate, better use that equation, or you can just use here 360 divided by 360 divided by 5. 360 divided by 5. You can use manually, or you can take it as input. So you can just go to sensing and then ask you how many sides you need. How many sides? So the answer which is given, you can use here as well as here. So then when I click this, it's asking how many sides you need. Let's say 5 sides. It's pentagon 1, 2, 3, 4, 5. Right. So let's say again, I'm clicking and it's asking how many sides, 3 sides. So it will go 1, 2, 3. So now this is generally for anything. So this is repetition. So let's say 7 sides. 1, 2, 3. So when you hit, when there is a border, when it hit the border, the angle will be different. That is the nature of stretch stage. When it hit the border, it will change the angle. So therefore, you have to be careful when there are 7 sides. Let's reduce the number of steps and make it smaller. Then it won't be affected. How many sides? 7 sides. Now let's try it. So if it is not hitting the border, okay, done. Let me run it again. How many sides? 7. 1, 2, 3, 4, 5, 6, and 7 sides. So it is repetition. So you can make it faster by removing the wait 1 second. So then this will be faster. 8 sides, instant. Click it. 9 sides, instant, right? Okay. So you can keep, so if you want to make it more complex by adding nested loops, you can add some more. So let's add a nested loop, that means loop inside a loop. So let me repeat 36 times, and each time I'm going to draw this. I'm going to draw 36 times, but after drawing, I'm going to change the angle by 10, right? So not move 10 step, I'm going to change the angle by 10. So you can use either side, left side or right side, that doesn't matter. 36 into 10 is 360, means you are going to rotate a circle, right? Let me show you the repetition inside repetition, and I click this. How many sides? Let's say I need 6 sides, so it's going to repeat 1, 2, 3, 4, 5, 6, 7, and 36 times and draw this kind of shape. So this is repetition, which is fundamental to this. So now you know what is repetition and how we can use repetition inside repetition. So by doing that, by changing the pen size, by changing the color, you have these options here. So you can do many things, right? I hope this is clear to you now. So let's go to the recursion. In the recursion, without using these loops, you are going to use functions. So in functions can be obtained in Stretch. Functions can be obtained by going to my block and making a block. My block and making a block. Let's create a function. So let's say, okay, let's use very simple one, print nums. I'm going to print nums from 1 to 10. So let's add input and I'm going to start from n. n is unknown, it's a variable here. Print num is a function. The function is going to take the input n and going to apply that throughout the function. So let's treat okay here. No, print nums n. So I need to do this from starting from 1 to 10. So let's say I need to do from 1 to 10. So what I need to do is I need to print that. Let's print it. I have to display there. So display, say, not hello this time, say n. And after each n, I can wait 1 second, right? But before doing that, I have to check one thing, that is this. Let's use the operations. That is, this n is greater than 10. If it is greater than 10, I'm going to stop that, because I don't want to run that. I need to stop this script. If it is greater than 10, that I need to check first. If not, I'm going to say n and repeat. Then the second time, I can call the same function. This is what the recursion. So if you run this one time, okay, let's run this one time first. Let me go to the control events again, and when space key is pressed, I need to run the block. I need to give 1 there to start. When I press space key, okay, still not run. I press space key. What's going on? N less R, so it should be other side, right? If n is greater than 10, if n is greater than 10, so let's press space, and it says 1, only 1, right? It's not going to go to the next iteration. Not going to go to the next iteration. That means not recursing. But to apply this recursively, I can call the same function inside the function. This is defined the print num. That is the function. Inside that, I can call the same function. So here, okay, I'll use from the operations. I'll use time this n plus 1. So I'm going to go to the next iteration. Let me press the space. Now starting from 1, 2, 3, 4, 5, 6, it will go up to 10. But when it is more than 10, it will stop. So this is what the recursion is. So you are not using repetition. Repetition you have straight away there. Recursion is a function, that is, you have created that by giving an input. So function is a set of related codes. So you have created that with the print num's name, and you are using that and doing the same thing, calling the same function again and again. Similarly, you can call, so this is anyway happening 10 times now. No? This is happening 10 times. Inside that, you can do the same thing. Let's say I need to draw a shape with 10 sides, so I can do the same. After this is the controller. I don't want to display this n. Instead of that, if I want to do something 10 times, I can do it here. So let's say move 10 steps and turn. So let's say 10 times 36 degrees. 36 degrees. Move 10 steps, turn 36 degrees, and I'm going to erase all again and pen down. After that, drawing this. So let's see what will happen. When I press the space key, okay, you can see it's smaller, right? It's very small. So each time it's erasing. So I should actually, this should not be erased. So erasing should be done only once, and pen down should be done only once. So it's my mistake. Okay, let's see now. Space key. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, this comes because we have taken that. So let me stop. Now space. Now you can see it's not coming. I can remove a few things to make it speed. Like let's remove this, wait 1 second, I don't need that. Say n, I don't need that. And move in, let's say move in 30 steps. And let's make it faster. You can see it's showing the same thing. So this is using recursion. This, when I press the space key, it uses recursion to do the same. But recursion is much complex than repetition. Repetition is straight away there. Recursion, you have to create that. Right? Okay. Then the advantage of recursion is we can apply, this is like a template. So we can use the template and do it again and again. So I'm going to show you some interesting things that is heading of this, which is a fractal based tree. So in the fractal based tree, because I'm going to apply the same machine, same template again and again, let me show what I'm going to do. First, I'll draw a branch, or I'll draw the stem. And after that, I'll reduce the size. So let's say this is, for an example, let's say this is 30 pixels or 30 steps. Then I'm going to, let's say I'm going to reduce 10 from that. 30 minus 10 is 20. So I'm going to turn, let's say 20 degrees and then 20 pixels, 20 degrees, 20 pixels. Then again, reduce the number. Then let's say 10 pixels and 20 degrees, 10 pixels. And after that, if you can again put a check. If it is less than 10, need stop. Come back, then turn. So initially we have turned 20 degrees. So let's say this is 20. This is how I'm going to draw this, right? Let's assume this is 20 and this is also 20. So I need a branch. So therefore I need to put 40, turn 40 degrees other side. Double 40 degrees other side, draw the branch. Come back to the initial position and draw the branch. 40 degrees this time, right? And recursively, I'm going to apply the same pattern. Go back and then come back here and stop from the initial position. So you can see this is very small tree structure. So let's see how we are going to apply that for recursion. To make it easier and shorter, I'll show you the final results, which I have added the recursion and repetition both together. So let me explain the code now to you. Here, I have taken tree. Tree is my function name, X, and this is to set the pen color. So then I'm initially checking if it is less than 5. This can be any number. If it is, because I'm going to start from 40 and reduce 5 by 5. I'm going to start from 40, reduce 5 by 5. Then my number of branches will be, so initially it is 40. 40 minus 5 is 35. 35 minus 5 is 30. 30 minus 5 is 25. 25 minus 5 is 25 minus, I have to reduce the size of the branch as well, sorry. That is this 25, 20, then 15, then 10, and after that I'm going to stop and come back. So that means my tree will have 1, 2, 3, 4, 5, 6, right? So if I'm going to reduce 10 by 10, that will be 4, right? So let's reduce 10 by 10 to make it easy. I'm going to reduce 10 by 10. Now I'm going to check whether it is less than 10. And this is also 10. Yes, I'm going to reduce 10 by 10. So let's do that now. And this is just to draw some, I have used repetition here. This repetition is to draw something at the end. Let's remove the repetition. Let's keep this code. This is only recursion. So start from, I'm going to start from 40, which is here. Then, so don't think about the colors, don't think about the starting position, direction. So we have learned that actually. So I'm going to stop the script when the branch size is less than 10. So first move in 40 steps, turn 30 degrees, reduce 10, that means 20, then turn 60 degrees the other side, applying the same recursive function tree, so to the other side, right, by drawing 20 degree branch, 20 pixel branch. Again, in the next round also, so it will be 10 less than that. So let's try to click that, and you can see 1, 2, yeah. This is 40, 30, 20, 10. right? So this is also to change the colors. I have used this change color by 60. Those things I have used to change the colors. You can see this is the color. And let's increase the number of steps by putting this there 5. If I'm going to reduce 5 by 5, then there will be 8. So let's run this. Okay, you can see. This is how the fractals are used. In the real life, so these fractals are used in vector graphic designing. And also, so this is how biologically the things, cell division happens and creating leaves, creating maybe a shape of animal or an organ or something is also happening just by subdividing or applying the same. So there is the same genetic algorithm in DNA. So sometimes with some mutations, some changes, with actually minor changes, minor tolerance value, the randomness will be added. So then the same machine is used to reproduce the cells, same DNA machine is used to reproduce cells, and that is what we are after all the mutations and all. So which the genes came from our parents, and this is what the final results, that is you and me. Okay, so this is actually a technical way of presenting such thing, but no mutations or no alterations will be the same machine, same template is applied. So you can change the color, you can make color change less dynamic by putting a small figure there. You can see it's less dynamic. And if you put 1 or some simple thing, so there will be a very minor change in the color. You can decide which color to start, which color to proceed. Likewise, you can decide what to do from that. So this is what we have. So you can change the number of degrees, that is your choice. Let's say in branching, you have selected 16 degrees. And here also 16 degrees. Then in the middle, it should be double of that, 32. So let's see that now, and you can see the angle will be less now. You can decide what to do, and you can decide the shape of your fractal tree based on the angle and all. So let's say you have used 24 there and 24 there. So you can put any, even 20 is okay. 24, 24, then this should be double of that, 48. Otherwise, so if you put something like 47, there will be, like you can see. So this is what happened when you use some other number, right? So therefore be careful. Please use the exact amount. Otherwise, so when it recursively applying, it's changing the. You can see this is also nice. So let's make color change more dynamic by adding 90 there. Finally, a blue color branch. Let's say 80. So you can try different figures, different values. I need actually the green leaves. So let's use 70. What's the end? Still not green. Let's use 60, because ultimately I can get. I'll be able to get. Okay, still blue color at about 50. No, so let's use 60. It's okay. So don't think about branch much. Let's use 60 there. You can decide, so when you want, you can decide the best figures to do that. Okay, here in this one, so except so I'm not drawing any shape in the middle. When it is less than 10, that means at last, when it is less than 10 or less than 5, let's say less than 5, less than 10 also you can apply. I'm going to apply this part. Actually, what this does, let me check, let me show this separately. what this part is going to do, when I press the space, I'm going to simulate, okay, you can see, it's going to draw this kind of shape. Okay, let's put that part to the end. Now let's recursively apply the same thing. And if it is less than 10, I need to apply, not less than 5, sorry. No, otherwise, if it is less than 5, this will be stopped. So if it is less than 10, before that, I have to apply. So let's see, okay, now we can see at the end of the leaves, it's applying this and keep applying the same thing. This will take some time, but this will create a tree which has some leaves at the end. So this is my way of telling that, but you can creatively apply anything and do this. So I encourage you to enjoy the fractals. So explore more. You can search fractals in Google. So in the fractals, here there are nice designs, nice patterns you can imitate and you can try to create. And this is tree, the fractal tree that we have just created. And there will be more fractals. Just give a try with more branches and with different shapes. So ice flake and all different things can be created, snowflake. So think about these things, do these things, practice, and you will be enjoying recursion with this. Right, then let's see you all with another video in the next day. Thank you, goodbye. Please do not forget to subscribe and give your support. Please do not forget to share the videos. Awesome.